Alrighty, so we are now on to part 2 of 4.4, and this is dealing with fractional exponents. So the last time we learned is that your index of your radical actually becomes your denominator of your fractional exponent. Now what happens when you have a power occurring to your radicand? Well, what happens is this power becomes the numerator, and your index becomes the denominator of your fractional exponent. So you can see here it's kind of laid out for us. And something interesting is that your radical can be done two different ways. So here we can see that our power is applying first before our index, but you can actually apply your radical before your power. Okay, so let's do a quick little example over here. So let's take 8 to the power of 2 over 3. Okay, we can do this way first and then this way second. Let's maybe focus on this way. So here n is 3 and m is 2. So this will become the cube of 8 squared. And here I can square 8 and I'll get the cube of 64. And now this is a little harder to understand. The cube of 64, well, you might not know immediately that that's 4. Okay, let's do it the other way and see if it's any easier. So here we have 8 to the power of 2 over 3. So I can represent this as a radical and put my cube root of 8. And now I'm going to apply that square after. Now that I've applied the square after, the cube root of 8, you should know by this point, is simply 2. And then that thing is going to be squared. 2 squared is way easier to do with. That's 4. So you get to the same answer, but here I first cube rooted before squaring, and here I squared before cube rooting. So there's actually an obvious easier path to take here, which is the below one. Now that's what you have to learn how to go about, which one's the easier path. So let's look at a few examples. But recognize we have added to our toolbox. So my fractional exponent here, sometimes you might have a power, and that power becomes your numerator in your fractional exponent. Your index still stays as the denominator. Okay, so here's all the tools that you kind of have so far. Now, let us go and do example 6. So example 6 says represent your fractional exponents as radicals and your radicals as fractional exponents. Okay, so here we need to represent this in terms of a radical. So remember that our power in our fractional exponent stays as the power here. Our denominator in my fractional exponent becomes the index. So what's going to happen here is this will be the cube root of 27 squared. We could also represent this as the cube root of 27 and that whole expression squared. Okay, see how they look different, but they'll be the same answer. This one I cube root 27 first, this one I square 27 first. The obvious way to solve this would be cubing it first, because it's way easier than squaring 27. But that's for example 7. Let's maybe try example our second part here. So square root 81 to the power 4. So here I have a power, and remember when we don't have an index, you can assume it's 2. So this will be 81 to the power of 4 dividing 2. And we can actually simplify that. 4 divided by 2 gives me 2. So this is actually 81 squared. Okay, and we'll figure out what that equals using our calculator in the next example. And then finally over here, we have the cube root of negative 125 squared. So let's solve this. My cube rooting will become a denominator in my fractional exponent. So this will be negative 125 to the power of 2 over 3. Now recognize it's really important that we include our brackets here because this is much different. Why is this different? Because if you plug this in your calculator will bracket just 125 and solve this first, and then you'll get a negative number. Here we have to get a positive number, so this is wrong. Okay, and if you're confused on why that's wrong, please definitely come see me or email me or ask any questions, okay? So now let's go to example 7, and actually solve these. So there's kind of a clear way to solve these. Right here, I'm not sure how to solve it like this, but writing it like this makes it way easier. So the cube of 27 squared. I can determine what this is. The cube of 27, the cube root of 27, I know is 3. Okay, so the cube root of 27 is 3 because I know 3 cubed equals 27. So that means 3 equals the cube root. That's an ugly looking 3. The cube root of 27 is 3. And then here is very easy to understand. 3 squared, well, that's simply 9. So this thing equals 9. Okay, let's go over here. Remember, we were able to simplify this using exponents, so this is way easier to plug into my calculator than, say, this. So all I have to do is plug in 81 squared. Again, do I know that off the top of my head? No way. But this is much easier to plug into my calculator than, say, having to do square root 81 to the power of 4. Okay, it's the same answers, just two different ways to represent it. Okay, so let's maybe represent this a little nicer. 6,561. There you go, there's your answer. And over here, is putting it in terms of fractional exponents very useful to us? Not really. But understanding this section of our exponent and radicals definitely will help us solve this. Because here, I can represent the cube root of negative 125 squared as the cube root of negative 125, and then I can square that thing. Because hopefully by this point, you understand that what the cube root of negative 125 is. If you don't, that's okay, let's figure it out. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. There's our solution there, and this means 5 equals the cube root of 125. Now recognize that it's a negative inside. You can cube root a negative because the index is an odd number. Remember, we talked about that in our very first video for chapter 4. So this will be negative 5 equals the cube root of negative 125. Okay, so this will be equal to negative 5, and that thing's going to be squared. And now negative 5 squared, well, that's negative 5 times negative 5. That gives us positive 25. We get positive 25 because a negative and a negative give us positive. So this thing actually equals 25. Okay, so hopefully that all made sense. Let's move on to example 8. Oh, forgot to delete this section here. Let's cut. So let's move on to example 8. And here we're going to have to evaluate these using our calculator. Okay, so understand something. Understand that this negative is being applied to this number. Okay, so it is not negative 1.9 to the power of 3 over 5. This does not equal negative times 1.5 to the power of 3 over 5. These are two separate things. Okay, so how can I plug this in my calculator? Well, I would probably actually just simply do negative, and then I'm going to bracket that thing. Okay, the reason I bracket it is because if I do 1.9 to the power of, and now I do 3 over 5, I will get negative 1.469. Okay, why did I utilize those brackets? Because if I see it as negative 1.9 to the power of 3 over 5, this actually will be the same thing because we're dealing with odd numbers here, right? So hopefully that made sense. Let's move on to this guy here. So we have the square root of 9.024 to the power of 4. So what I'm actually going to do is, remember, if you don't have an index, you can assume it's 2 there. So I'm going to represent this using fractional exponents. This will be 9.042, divided by, or to the power of 4 dividing 2. Okay, so we took my index, put it in my denominator, put my power as my numerator and my fractional exponent. This can be simplified. This will be simplified into 9.024 to the power of 2, because remember, 4 dividing 2 gives me 2. And now this is way easier to plug in my calculator, okay? So if I pull out my calculator, and I do 9.024 to the power of 2, that gives me 81.43. Okay, so this thing equals 81.43. If I'm really good with a calculator, I could plug in this whole thing, okay, into the power of 4, but you'll get the same answer. Recognize your calculator has a lot more potential of error, whereas if you know how to simplify things using your brain, you'll be much better off. Let's look at this last one here. So how am I going to plug this into my calculator? I notice that I have a 7th root of negative 1.45 to the power of 3. Plugging this into my calculator will be much easier if I show it as a fractional exponent. So recognize I keep the brackets around my number. My power will become my numerator of my fractional exponent, and my index will become my denominator. So now I really have to just be aware of my brackets. So this will be bracket negative 1.45 bracket to the power of, and I'm going to bracket 3 over 7. So depending on how good your calculator is, this might be really easy with the type of calculator you're using, or it might be very difficult. So if this doesn't pop up as exactly, I would practice plugging this in, and if it's not showing up the way it should, you definitely want to come in and see me, or ask me how you can utilize your calculator a little better. So this will become negative 1.17, and that is your solution. Okay, so that is the end of chapter 4.4. Okay, so if you could go check your understanding with AFL 4.4, that would be great. If you need to come in and ask questions, please do so. Ask tons and tons of questions, as this is when math starts getting a little difficult. Okay, this is when Math 10C starts to feel a little hard for some people. Other than that, have a good day.